Hello and welcome to helpyourmath.com. In this video, we're going to look at an introduction to piecewise functions, what they are, what their domain is, and how to evaluate them. So, what is a piecewise function? A piecewise function is a function comprised of pieces of various functions. The domain must be specified within the function itself, and it is behind the pieces that it applies to. So, an example of a piecewise function could look something like this. In this case, we're saying that f of x, this function, will have this mapping 3x minus 2 when x is less than 9, or it's going to be given by this piece of the function when x is greater than or equal to 9. So notice that we're always given the domain here, so this is the domain, this is where the pieces are defined. And so what we're doing when we're plugging in various values for x is we have to decide which piece it belongs to. Usually I refer to these as like this is the top piece and this is the bottom piece. And remember, for it to be a function, we only plug in domain values once. We only plug in inputs once. So if we have x equals 7, we only either plug it in to the top piece or the bottom piece, depending on where it works for the domain. Since 7 is less than 9, we would apply it to the top piece. So that's what a piecewise function is. This particular piecewise function is comprised of two linear pieces, right? Because 3x minus 2 is a linear equation and 1/3 x minus 7 is a linear equation. The domain of this function, well, while there is a split in the domain, sort of, like it just gets broken up because it's a piecewise function, but otherwise we can plug in any real number. There's no restrictions. So we would say it's from -infinity to infinity. We can plug in any value. Every value belongs in either the top piece or the bottom piece. Now let's evaluate. So f of 0. So we have to decide f of 0. I'm going to erase this. Where does 0 make sense? Is 0 in the less than 9 category, or is 0 greater than or equal to 9? Whichever one is true, that's the piece we plug into. This is false, meaning we're going to plug in 0 to the top piece of the function. So we would say 3 times 0 minus 2, which is -2. So f of 0 is -2, right? Every input has exactly one output, so 0 only maps to -2. That's it, the end. What about f of 9? So 9, we have to decide, is 9 less than 9, or is 9 greater than or equal to 9? This is the one that's true, this is false, so we only plug in 9 to the bottom piece. That'd be 1/3 times 9 minus 7. 1/3 of 9 is 3, and 3 minus 7 is -4. So we would say that f of 9 is -4. And last but not least, 12. So now we have to decide, is 12 less than 9? No. 12 is greater than or equal to 9, so we only plug in 12 to the bottom piece. So f of 12 is going to be given by 1/3 times 12 minus 7. 1/3 of 12 is 4, and 4 minus 7 is -3. So f of 12 is -3. In our next example of a piecewise function, this time we're given g of x, and again there's two pieces. So again we have our top piece and we have our bottom piece. You'll notice these are not linear. The top piece is a cubic function and the bottom piece is a square root function. The domain for this function, so this function is defined anytime x is less than -2. So we're going to say from -infinity to -2. And then it's defined when x is bigger than or equal to 5. So we would say 5 to infinity. And that would be the domain. So there's nothing exists between -2 and 5. Okay, now let's evaluate g of -3. So we have to decide which piece does -3 belong to. The top piece, where -3 is less than -2, or the bottom piece, where -3 is greater than or equal to 5. This is false. This is true. So we only plug it into the top piece. That would be -3 cubed minus 9. That's -27 minus 9, which is -36. So we would say g of -3 is -36. Next up, we have g of 5. So we have to decide, where does 5 belong? 5 belongs in the bottom piece, right? Because 5 is greater than or equal to 5. So we would say the square root of 5 plus 4. That's the square root of 9, which is 3. So g of 5 is given by 3. And last but not least, we have g of 8. G of 8, that would be the square root of 8, oh, I'm sorry, I didn't explain it, but 8 is bigger than or equal to 5, so it belongs in the bottom piece. So we only plug it into the bottom piece. The square root of 8 plus 4, that would be the square root of 12. 12 could be the square root of 4 times 3, so that'd be 2 radical 3. I didn't say these had to turn out pretty, did I? We get g of 8 is equal to 2 radical 3. So that's what we would do for this particular piecewise function. Another example. Here we have h of t, and we have the various pieces. So now we have 3 pieces. We have the top, the middle, and the bottom piece. So the top piece only applies to when the input values are less than or equal to -3. The middle is in between -3 and 0, and the bottom is only when the values are positive. The domain of this function, there's no break in the domain, right? It goes till -3, including -3, and then here it picks back up at -3 and goes to 0, and then here it continues from 0. So the domain is going to be from -infinity to infinity. And now let's look at plugging in some inputs. Ooh, we're going to plug in a lot here, so I'm going to start all the way up here. H of -4. Okay, where does -4 make sense? The top, the middle, or the bottom? So is -4 less than or equal to -3? The answer is yes, so we can stop there. We know that -4 belongs to the top piece and only the top piece. We're going to plug it in. That would be -4 squared plus 1. -4 squared is 16, but that negative in front gets treated as multiplication and gets attached after. -16 plus 1 is -15. The second example, we want to evaluate h of -3. Where does -3 fit? -3 fits right here, right? Because it's less than or equal to -3 itself. So this would be -3 squared plus 1. This piece here is 9, and then we attach the negative, so it's -9 plus 1, which is -8. I'm going to just go ahead and put these over here. So h of -4 was -15. H of -3 is -8. Next, we're looking at h of -1. So where does -1 fit within the domain? -1 is bigger than -3, so it's not the top. -1 is in between -3 and 0, so we're going to plug in -1 to the middle piece. That would give us the absolute value of -1 plus 2 minus 4. That would be 1 minus 4, and 1 minus 4 is -3. So h of -1 would be -3. 2 left. H of 0. So where does 0 work? 0 goes in the middle piece because that's the one that includes it's less than or equal to 0. So we plug in 0 into the middle piece. That would be the absolute value of 0 plus 2 minus 4. 0 plus 2 is 2. The absolute value of 2 is 2. 2 minus 4 is -2. So we get h of 0 equals -2. And last but not least, we're going to evaluate h of 3. Where does 3 work? Where does it fit in which piece? The top, the middle, or the bottom? 3 is greater than 0, so we only plug it into the bottom piece. H of 3, that would be 1/2 times 3 minus 7. That's 3 halves minus 7. I'm going to rewrite 7 as 14 halves, just so that they have the same denominator. We end up with -11 halves, or -5.5. So when we look at h of 3, we get -5.5, -5.5, -11 halves. Any one of those 3 is fine. These have been some examples of the definition of a piecewise function and also plugging into piecewise functions. Thank you for stopping.